hydrograph is often produced based on a storm with certain duration and rainfall excess. From here, we may develop a unit hydrograph for a specific storm duration and a unit rainfall excess, let's say 1 mm. Unit hydrograph is essentially an effective hydrograph, represents a catchment's response to a unit rainfall excess under a storm lasts for d hour. To derive a unit hydrograph, we need hydrographs from a few isolated storms with approximately the same duration, preferably from 0.9d to 1.1d. In our example, the duration for the first hydrograph, H1, is 6.5 hours, while the second one, H2, is 6 hours. Both would serve as an appropriate reference for us to derive a 6-hour unit hydrograph. The catchment area for our study is 378 km². When selecting hydrographs, we should look for those produced by storms that cover the whole catchment. The hydrographs should then go through the base flow separation process. In this example, let's adopt straight line method. For catchment area of 378 km², N is found to be 2.72 days, which can be translated to 65.3 hours. The peak flow occurs at the 33rd and 18th hour for H1 and H2 respectively. Therefore, the location of point B is conveniently taken as 97.5 and 84 hours respectively. 17 Qmax is associated with point B for H1, while that for H2 is found to be 16 Qmax. In other words, we can offset the hydrograph downwards by respective magnitude and derive two direct runoff hydrographs from H1 and H2. For each direct runoff hydrograph, we determine the direct runoff volume by calculating the area under the hydrograph. Implementing trapezoidal rule would be a good way to calculate the area under graph. The effective rainfall depth can then be calculated by dividing the direct runoff volume with catchment area. As a result, the effective rainfall depth for H1 and H2 direct runoff hydrographs are 39.6 mm and 29.1 mm respectively. Then, we proceed with scaling down the ordinates of those hydrographs with respective rainfall depth. For instance, hydrograph H1 is resulted from 39.6 mm of rainfall excess. Therefore, we would divide the ordinates by 39.6 mm to produce its own hydrograph. For H2, the factor should be 29.1 mm instead. Once we successfully derive unit hydrograph for each of the storms, we can combine them into one by taking the average of their ordinates. Thank you for watching. If you find this video helpful, please share it with your friends. We will see you guys soon. Goodbye.